Hello guys, I am Hitesh Tripathi and this is editorial video for problem A and B from weekly contest 273 LeetCode. Okay, so problem: a number after a double reversal and execution of all suffix instructions is staying in a grid. Okay, let's just see first question. Here we have a number after a double reversal. Reversing an integer means to reverse all its digits. It is obvious. Okay, for example, reversing 2021 gives 1202 and reversing 12300 gives 321 because we lost these two zeros when we have reversed this number. Okay, as the leading zero are not retained. Given an integer num, reverse num to get reversed 1 and then reverse reversed 1 to get reversed 2. So means we have to do reverse operation 2 times. Okay, fine. Return true if reverse 2 equals to num, otherwise return false. So kind of easy question, that's why difficulty is easy. Num is 526. We will reverse it once, it will get 625, and we will reverse it again, it will again get 526. So obviously it will be equal, we will return true. Otherwise, suppose this example, we have 1800, we will reverse it and we will get 81, and after that when we will reverse it again we will get 18. So these both numbers are not equal, so obviously we will return false. So in a simple way you can say that any number in which we have 0 in the end, okay, if it has single 0 in the end or more than 1 0 in the end, we will simply return false, otherwise we will return true. Okay, so and there is one more example, that is 0. So in that case this method will not work obviously, because it doesn't matter how many times we reverse 0, it will simply become equals to 0 only. Okay, so that's why one method can be you can reverse it 2 times. Okay, and simply these 0 will get out from this number. Okay, otherwise you can simply what you can do is you can simply check whether this number is divisible by 10 or not. If it is, it means we have a 0 in the end of the number. Okay, and if it is not, it means we do not have a 0 in the end of the number. So and one more edge case which we have to check is num should not be equal to 0, because in that case we have to return true simply, because I have already told you. So simply check if num is divisible by 10 and num is not equals to 0, return false, otherwise return true. Okay, so this was an easy question. Let's see second one. That is a medium question, but kind of it is also an easy one because of its constraints. Okay, execution of all suffix instructions is staying in a grid. There is a n cross n grid with the top cell at 0 0 and the bottom right cell at n-1 n-1. Okay, you are given the integer n and an integer array start position, where start position is equals to start row start column, indicates that a robot is initially at the cell xy. You can simply say at the shell start row start column or xy. You also given 0 index string of length m, where si is the ith instruction for the robot, l moves left, r moves right, u means up, d means down. Okay, now the robot can begin executing from ith instruction in s. Okay, it executes the instruction one by one towards the end of s, but it stops if either these condition is met. The next instruction will move the robot off the grid. Off the grid simply means suppose you are in this shell right now, that is 0 and 2, and you have to move right, so obviously you will get out of the grid. Okay, or suppose you are in this shell right now, that is 2 2, and you simply have to move right or down, so it is simply easy to see that you will get out of the grid. Okay, so this is something question is saying that in these two cases you will stop whether you are moving out of the grid or there are no more instructions left to execute. Return an array of answer length m, where answer of I is the number of instructions the robot can execute if the robot begins executing from ith instruction in s. Okay, so in easy way what the question is saying is, suppose you have a string, suppose let's just see this example. You have this string s r r d d l u. It means if you started from ith index executing the instruction, you can get r, go to right, right, down, down, left, up. Okay, and this is your start position, that is 0 1. Suppose let's just start executing instructions from starting index, right? You will get in this position. Okay, then again write. After executing this second write, you will get out of the grid. Okay, so you can say that if you start executing instructions from 0 index, you can simply execute at max one instruction only, that is you can get to this position only. After that you will get out of the grid. Okay, so for first index you will simply print the output as 1. That means at max you can simply execute one instruction only. Suppose let's just start from first index, that is simply first index. Okay, now let's just execute instructions. That is, you will get here right, then down, second index, down, then again down, okay, then left, then up. Okay, and after executing this instruction, we do not have any more instructions left with us. Okay, so at max we can execute 5 instructions starting from index 1. Okay, that's why in this index we have 5 as answer. And when we start from executing instructions from second index, we have to tell what are the maximum number of instructions we can execute from this index, starting from this index of the string. Okay, so let's just see the constraints for this question. And constraints for this question are very low. Okay, like we have a grid of 500 cross 500. Okay, so somewhere if we do execution from every index. Okay, so suppose this is a string and this is your string. Suppose we have 5 length string, that is L L U D M. Okay, suppose you started executing from here and you check complete string, then from here and checked complete string, then from here and checked complete string. So at max you are going to check string length square indexes. Okay, or if your string length is m, so you are going to do m square executions or m square checkings. Okay, so you can simply say that if we do apply brute force in this question, maximum complexity for this question will be at max m square. Okay, because m is the length of a string. Fine, so and m square is not going like can easily be executable, that because it will be simply 10 raised 4 order. So let's just see simple execution. There is a function called isValid which will simply check whether current shell, that is x and y, is inside the grid or not. Okay, so x and y are current shell coordinates. It will simply check x is greater than equals to 0, y is greater than equals to 0, and is under the constraints, that is if x is less than equals to n minus 1 and y is less than equals to n minus 1, it will simply return true, that these current shell, that is x and y, is valid. Otherwise it will return false. Now what I will simply do is I will have a answer vector where I will store answer for each index. Okay, and now I will simply start iterating for every index of the array, and now in xy I will have a start position, that is my current shell, that is the start position. Okay, start position 0 will be my x coordinate and y will be my start position 1. Now we will start execution from ith index in the string, that is I will iterate from ith index up to s length, and I will simply check whether s of j is u. If it is u, I have to move upwards, so I will simply subtract 1 from my row. If it is l, I have to move left, I will simply subtract 1 from my column, and in the same way vice versa. Okay, at the end, after I will execute current execution, I will simply check whether this current shell, that is valid or not. Okay, I will simply pass x and y in the function. If it is valid, I will simply increase 1 in my variable, that is count. Okay, and if it is not, I will simply break from here, that is I can't execute any more instructions, and at the end I will simply push count in the answer vector, and in the end return it from here. Okay, so thank you guys for watching this video. For more editorials from the same contest, simply just subscribe this YouTube channel and like this video. Thank you guys for watching.